And so what's the test statistic? 5. It's a plus 5. Right? And so where does it fit into this decision rule? Well, it's way to the right of 1.645. And so tested, how does it falls into which region? The acceptance region or the rejection region? It falls into the rejection region. So reject HO, right, and accept H1. So that's what we do. What we do is we go back to HO and H1. We reject HO and we accept H1. And what does H1 say? Mu is greater than 20 minutes. Correct? And so the question is mu less than or equal to 20 minutes? And the answer is no. And so therefore, this is false, this statement, that hypothesis. Okay? Everybody follow that? Anybody have any questions? So, that's hypothesis testing for, in this case, where we have 6 steps in hypothesis testing. First one, state the null, state the alternate. Like I said, very critical piece of information is that when you set up HO, always remember that the equals is in HO. Select the level of significance. You get to choose it. 0.01, 0.05, 0.10. Take a sample of size n. You get to choose the sample size based on time and money. You calculate whatever statistics you need. And in this case, what do we need by way of statistics? Well, we need everything to fit into this thing. So what's that? The hypothesized mean, which is part of the test. It's right there, 20. X bar, so you have to calculate a sample mean. Sigma, for some reason we knew sigma. And you have to know the sample size. So those all plug into here. Then it's a Z or a T based on the decision tree. Select the test statistic based on the decision tree, Z or T. Formulate the decision rule based on the, using the critical values or with the critical values, and that's based on the handout. And then you make a decision about HO, and the way you make the decision about HO is how does the test statistic fit into the decision rule. And so once you see how the test statistic fits into the decision rule, we make our decision on HO, and then you accept HO. And so what we say here is that we reject HO and accept H1 at the 0.05 level of significance. Similarly, you know, when we said, well, we're 95% confident that mu is somewhere between this number and that number, here we're saying kind of the same thing, that we're rejecting HO, accepting H1 at the 0.05 level of significance. So you have to tell when you make your decision what the level of significance is because people want to know, well, how often are you going to be right or wrong as it relates to our decision here. And in this case, we can live with alpha at 0.05. Live with alpha at 0.05. Let's say alpha was 0.01. What changes? None of the statistics change. The only thing that changes is where? Where does alpha come into play? Alpha comes into play here. It's not 0.05, it's 0.01. And so, in this case, if this is a 0.01, what's the Z? Well, that makes this a 0.49. And so when you look up in the chart, or in the table, you look up the closest thing to 0.49, what do we see? We see 0.4901. it's 2.33. And so the critical value is not 1.645, it's 2.33. And so, if the test statistic is less than 2.33, then accept HO. If not, reject HO and accept H1. So even if we had been at 90, I'm sorry, if this had been alpha is equal to 0.01, let's say we changed it, 5 is still to the right of 2.33, falls in the rejection region, and we're still going to make the same decision. We reject HO and accept H1. Okay? Anybody have any questions before we do another one? Well, this time we'll do pi. We'll do something on pi. Well, then I have to do a t. That's right. Good. I have to do a couple of them because here we just looked at the z distribution. I have to show you one with the t distribution. But before we get that, you get a question.
Yes. So when you're describing your statement, what's the difference between accepting HO and accepting H1?
I don't understand. What do you mean?
So you find the answer and you decide that you're gonna reject HO and accept H1.
Right.
How do you describe that again? Towards the statement that's made.
Yeah, I probably go to okay, a couple of things. What we start out with is we start out with some claim, and then we say that, oh, we're going to test this right here. And so in this case, what happens is what we're testing is the null hypothesis, right? And then the alternate, in this case, goes in the alternate. It's not always going to be that way because, like I said, if we were testing more than 20 minutes, if this were going to be more than 20 minutes, let's say it takes more than 20 minutes, this would be the alternate. Correct? You understand? Yep. Okay. So let's go back to what it said here. Less than or equal to. Okay. So you put an HO and you put an H1, and then you pretty much forget about it, because then you deal with the level of significance. Then you deal with the sample data. Then you come over here and you say, oh, we have a Z over T. In this case, we had a Z. And then you have this Z distribution. And then you put in the critical values. And then you make the decision. You take the test statistic and you fit it into the decision rule. Now, what it says here in the decision rule is it says, look, if the test statistic is here, this is accept HO. If it's over here, we reject HO and accept H1. All right, so in this case it was 5. It's over in the reject HO and accept H1, which just says over here. And then you basically say, man, it's been a long time, I forgot what they were. So all you do is you go back over here, because you know you set them up correctly, and it says reject HO and accept H1. Correct? And then usually what you do is you say, okay, what were they asking me to test? And they were saying they want you to, it takes within 20 minutes to feel better after taking this pill. And so the way we designated it was mu is less than or equal to 20. That was HO, we rejected it. And so really, the answer is no. Because they asked you, is this true? And the answer is no. Did you follow that?
Yeah.
Yeah. And so that's why I say that in hypothesis testing, really what we're looking for is yes or no. Is the hypothesis true or false? But for our purposes, you have to show me all the work. Because if you just answer true for question 1, I say run a hypothesis and all you say is true, I'm not going to, even though that answer is right, or in this case, let's say it was false, and so that's all you gave me was the answer false, I'm not going to accept that. Because anybody could say that, true or false, true. Oh, why? I don't know, I'm just going to guess it's true. So when you do a hypothesis test, you have to show me all this work. Because I want to make sure you know how to do this. And so I want to see the 6 steps. I want to see the null and the alternate. I want to see it set up. HO is this. H1 is this. I want to see, well, the level of significance is always going to be in the problem anyway, but at least just designate it as 0.05. So I recognize that you recognize what the level of significance is. The third thing is to sample results. Now, a lot of times, that's already in the problem. You'll say X bar is 25, and sigma's 10, and N is 100, so you don't have to really write those down because they were given to you in the problem. But when it comes to the test statistic, I want to see the calculation. Okay? How you got it. And then I want to see the decision rule because I'm interested in the critical value. You don't have to graph it.
But you've got to tell me what the critical value is. And so what I tell students, I don't know how many years I've been teaching this, but I tell students all the time, this is what I do when I do a hypothesis test. I write down the 6 steps. I write down number 1, I write down number 2, I write down number 3, I write 4, I write 5, I do the graph because I can visually see it. And so when I'm doing it, I'm like, oh, I'm in the right. And so this has to be a positive critical value. And so then I take the test statistic, fit it into the decision rule, and I say, oh, look at this. It's reject HO and accept H1. Because what happens is a lot of times if you don't graph this right here, and you do the test statistic, you don't have the right sign on the test statistic. In this case, if this were a -5, let's say that the answer was not 25 but 15 minutes. That would give you a -5. Okay? And so the test statistic is over here someplace. And so what is -5 as a test statistic with this test? That's accept HO. Okay, so make sure you have the right signs on your critical values and on your test statistic because that could lead to the wrong decision also. And remember, this is a yes or no decision. And so if you don't do everything correctly, you're going to get the wrong answer, especially if you set this up wrong. What about if you set up HO this way? Mu is, well, first of all, yeah, if you said mu is less than 20 minutes, and then you said H1, mu is greater than or equal to 20 minutes, what's happening is you're testing the wrong thing. You really should be flipped, and you'd be rejecting HO versus accepting it, or rejecting it. So make sure that when you set this up correctly, the equality is always HO. That's one of the constraints on hypothesis testing. And so always remember that. 1, 2, 3, 4, 5, 6, 7, 8, 9. I get 9 students. 10. Guaranteed 2, maybe 3 won't set it up correctly. And so therefore you have to get the answer wrong. Okay? And so when I look at a hypothesis test, I look at a few things. Make sure you set up HO and H1 correctly. Alpha I don't really worry too much about. The statistics I usually don't worry too much about unless I've said, here's some data. See, that's another thing I can do. I can say to you, I want you to test whether or not mu is less than or equal to, mu is within 20 minutes. And I'll just give you the data. Not that I'm going to give you 100 observations, because that's what it would take in this case. But that might give you 10. And so that means you have to calculate out X bar. You have to calculate S, if S is what it is. So you have to know how to do the mean. Like I said, nobody ever has a problem calculating the mean. But when it comes to the standard deviation for a sample, make sure you know how to do it. Because if you don't know how to do it, what's going to happen? You get this wrong, it goes in here, you get the test statistic wrong, you get the decision rule wrong. Or the decision, because the test statistic is wrong. So I look at step 1 very closely, I look at step 4 very closely, I look at step 5, and then you have to make the right decision. You have to fit the test statistic into the decision rule. Okay, so make sure you're deliberate, you give me the information, and we go from there. All right? So, okay, now, somebody had the hand up, I can't remember.
It was me, but you answered it.
I did?
Yes, thank you.
All right, so let's look at another test. hypothesis testing is sort of the same coin as confidence interval construction, except it's the other side, because we see a lot of the same variables and calculations in hypothesis testing that you see in confidence interval construction. It's just another way to look at whatever the issue may be. And so, let's see, what we're going to test. What did we just do? We did minutes. We can do. Let's do. Even though this is a discrete variable, we'll go to income. Average annual income of an NU grad, 1 year out of college, is 60 grand. Let's say that Northeastern puts that in their flyer. They say you come to Northeastern, 1 year out of school, 60 grand, average. And so what we say is, well, let's go test this hypothesis or this statement that Northeastern makes. Let's see if it is 60 grand. And so how do you do that? You run a hypothesis test. And so if one were to look at this right here, what would we be testing? Is what? As it relates, are we testing mu or are we testing pi? We're testing mu. And we're testing is what? Is mu equal to 60,000? Correct. Because that's their statement. It said it is 60,000. And so we test this. And so if this is what our test is, what's the alternate to this?
It's not.
Not equal to. Okay, so this is what we're testing. We're going to run a hypothesis test. What's the first step? It says state the null, state the alternate. And so which of these two is the null hypothesis?
Equals.
Mu is equal to 60 grand. Versus mu is not equal to 60 grand. What's the second step on the hypothesis test? Level of significance. In this case, we'll do a 0.01. What's the third step?
Would the level of significance be given to us?
Yeah.
Okay.
Yeah. Well, if you're doing your own test, you get to
Yeah,
decide what it is.
yeah.
Yeah, you have to. I have to give you
Okay.
the level of significance. 0.01, 0.05, 0.10. Usually, I use 0.05.
Okay.
Every now and then, I use 0.01. And so, what's the third step in the hypothesis test?
Sample.
It says take a sample of size n. So let's say we take n is equal to 64. And we come up with the next bar. Let's say x bar is 58,000. Now let's say it's 59,000. No sigma. Let's say that S, meaning you have to calculate the sample standard deviation. That means you have 64 pieces of data. You got to calculate S. And let's say S is $8,000. Everybody know how to calculate S? Make sure you know how to calculate S. So those are the statistics. What's the fourth step in the hypothesis test? Test statistic. How do you do the test statistic? How do you decide? Decision tree. What's the first question in the decision tree?
Population normal.
Is the population normal? What do we say? We haven't said anything.
No.
we go to the left, correct? Is n greater than 30?
Yes.
Yep, how about, do we know sigma? No, so what box do we end in? We end in a box that's in like statistic 3. So we're like, oh, I forgot to say, probably have to tell you, let's assume a normal distribution. Now, after you take statistics 3, if anybody takes it, what happens is you get into what the hypothesis test looks like if you end up in that box. Here, since we haven't gotten that far, we're going to assume a normal distribution. And why are we going to assume a normal distribution? So that we can solve it. So let's go back up to the top again. First question, is the distribution normal? Yes, you go to the right. What's the next question? Is sigma known?
No.
Answer is no, and so you end up with the t, correct? Okay, so we have a t, the test statistic is a t. What's the calculation of the test statistic? That's the second page of the handout. What does it say? T little sub n minus 1 is equal to x bar minus mu sub h over s divided by the square root of n. And so, what's x bar? 59,000. Minus the hypothesized mean, 60,000. Divided by s, s is 8,000. Oh, great. This is a great one. Wait to see the answer to this one. That's what happens sometimes when you make up an example, things like this happen. And so then it's the square root of n. What's n?
64.
64. And so what is the test statistic t? T, n minus 1 is equal to what? It's 1,000 divided, oh no, actually it's going to be okay. 1,000 divided by 8,000 divided by 8. What's 8,000 divided by 8?
Negative 1,000, right?
Oh, excellent. Right, excellent. Just checking, making sure. Definitely. You can't get this wrong, otherwise I'll be on the wrong side here on the test statistic. And so it's 59 minus 60 is minus 1,000, and it's 8,000 divided by 8. So this is 1,000, right? Actually, no. What I said about this one isn't going to hold. All right. So the test statistic is what? Minus 1. And so what's the next step in the hypothesis test? Formulate the decision rule. And so, is this a one or a two-tailed test? This is a two-tailed test. Why is this a two-tailed test? Because it's set up like A, equal to versus not equal to. Correct? And so this is a two-tailed test, so we have two rejection regions. Over here is reject HO, accept H1. This is accept HO. This is reject HO, accept H1. And we have a positive critical value, and we have a negative critical value. And so, what are they? Well, what is this? This is a t-distribution. Okay, so you open up the t-table. Let's see how what the t-tables tell us. So we go up to the top of the table, and what does it say? Confidence intervals. Nope, that was last week. Okay. Then it says level of significance for a one-tailed test. Everybody see that in the table? Mm-hmm. Is this a one-tailed test?
No.
Nope, it's a two-tailed test. And it says alpha. What is alpha in this case? 0.01. So what we do is we look up 0.01, where it says two-tailed test. And it's the next to last column. Everybody see the next to last column? Everybody see that? This is 0.01, two-tailed test, 0.01. Right? Because that's what alpha is. You know, the way this book presents it is all of alpha in the tail, okay? And so we have to get degrees of freedom. So how many degrees of freedom do we have?
63.
Well, let's go see. Let's see if it's in the handout. Is it in the handout here? Does it say anything about degrees of freedom? Yep. Oh, there it is, yeah, right in the middle. See the top one in the middle? It says N-1 degrees of freedom, one sample. Everybody see that? Okay, and so one of the reasons why I like to designate the little subscript down here, N-1, is because that tells you where to go in the table. This tells you where to go in the table. And now this tells you where to go in the table because there are 63 degrees of freedom. So with 63 degrees of freedom and 0.01 in the tail, this would mean this is a 0.005, not that it matters. What's the positive critical value with 63 degrees of freedom?
2.387.
What is it?
2.387.
Anybody else, anybody agree with that?
No, it's 2.656.
2.656? Who says 2.656?
I did.
Anybody else?
2.656.
Whoa, you changed your mind?
Yeah.
How come?
Because I was looking at the wrong.
Right, exactly. Yep. So make sure now, remember, these are critical values, so make sure you pluck off the right one. Okay? You're right, it's 2.65, 2.656. Yep, 63 good. 2.656. So there's a minus 2.656 and a plus 2.656. And so what does this say? This says if test statistic T is between minus 2.656 and plus 2.656, then what do? If the test statistic T is between minus 656 and plus 256, meaning it's in this area here, what do?
Except.
Accept HO. If not, reject HO and accept H1. So that's the decision rule. And then the sixth step, make the decision, take the test statistic. Where does this fit into the decision rule? Minus 1 is somewhere between 0 and minus 2.656. So since the test statistic is minus 1 and falls in the acceptance region, we accept HO. And so because we're accepting HO, once again, you know, HO was like 20 minutes ago. We go over and we say mu is equal to 60 grand. At 0.01 level of significance. And so we go back and we say, okay, we're accepting HO, but is that what the hypothesis was? And the hypothesis was mu is equal to 60 grand. And so we say, what about Northeastern's claim? And the answer is?
True.
True. At the 0.01 level of significance. Okay? So when you look at this, you say, oh, it's kind of strange that simple mean was 59 grand, and we're saying that the parameter is 60. even though the sample mean is 59 grand. But you gotta remember, the 59 grand is only 64 observations. So this is not enough evidence for us to reject HO. Not enough evidence. What's the evidence? All of this stuff. All these statistics saying that, yeah, we recognize the sample mean, it's like 64 people. 64, even though that's less than what the hypothesis was. This is not enough evidence for us to reject that it's not equal to.
Is that .005 you have in each tail? Is
Yeah,
that what you have there?
.005. This is .005, because what's .005 plus .005, .010? And that's,
Well, that's what I was gonna ask, is, so the .01 is split between each tail.
only for presentation purposes.